Hello geometry students, this is Mr. Fugay, and this is part 2 of the reciprocal trig functions lesson. So please make sure, hopefully, you have taken a look at video number 1, where we talk about the reciprocal trig functions. So these are going to be our primary focus, but the one thing I want to remind you here as we begin the lesson is oftentimes what I'm going to do in most situations when we're presented with either the cosecant, secant, or cotangent ratios is immediately transfer it back to our more familiar sine, cosine, or tangent. And so remembering what the reciprocal of cosecant is, what the reciprocal of secant is, and cotangent is vital in order to work through a lot of these problems. So we're going to do some working backwards questions now here and start with this problem number 1. And the first thing we want to note right away is we are being given the cosecant of theta ratio as 20/12. And so what we want to do is to find all the missing sides and all the missing angles of this right triangle. So the first thing I'm going to do here is draw myself a picture and visualize what we have going on. So right away, just draw any old right triangle. I am going to label a theta in a specific spot, remembering that that's one of my acute angles, which we will be solving for at some point. But now here's the main thing I want you to remember. So when we're given cosecant, in this case, as 20/12, what I will often do right away, because I am more comfortable with this, is recognize that that's actually just the reciprocal of the sine ratio, which is 12/20. And so what that's going to tell me now is that the 12 is my opposite side, and the 20 will be the hypotenuse side when compared with theta. So I will put 12 here, I will put 20 here. So technically we already know two of our side lengths, which are, well, 12 and 20. To figure out the next side, we have basically, three things to solve for here. We have this x, we do have that initial theta here, and then I guess I'll call this other one y, the other angle. So first thing I think I'm going to do here is, since I already know two sides of my triangles, let's go ahead and just get the Pythagorean theorem out of the way. So we would get 144 equals 400, and then doing a little calculator work from here, that's going to give me 256. And finally, when I take that square root, I'm going to get 16 as my third side of the triangle. So the sides are taken care of, and now we just have to figure out the angles. So let's go ahead and let's start with that theta. And in fact, I'm going to go ahead and use the sine ratio that we just found here just a few minutes ago, because I can find theta immediately by just taking the inverse sine of 12/20 in my calculator. And so I press second sine if you're using the TI-30. If you're using Desmos, you can locate the inverse sine button in the functions menu on the calculator. And I'm getting an angle of approximately 36 it says 869, so let's go ahead and round that up to 36.9 degrees. So for my angle measures, I'm going to go ahead and acknowledge the 90 that I already have here. I get 36.9, which is right here. And then lastly, angle y here, I don't really need to do anything but use the triangle sum theorem. So when I do that, I'm going to get 53.1, and we have solved for the triangle. So one thing I want you to notice here is that the problems that I just walked through here are almost the exact same problems we were reviewing when we were solving right triangles just a class or two ago. And the only difference, the only new part of this problem is this first step right here, and that is converting our reciprocal ratio into our original sine, cosine, or tangent, depending on what its reciprocal is, and then just proceeding normal from there. So let's try one more. So we don't have one in our notes, so I'm going to make one up here. So let's go ahead and actually use cotangent this time, and I'm going to give you cotangent of theta as 15/7. All right. So we're going to go ahead and do the same thing. I want to figure out what my three side lengths are, so we'll just leave some blanks here, and then figure out what my three angles are going to be as well. So 1, 2, and 3. Okay, let's draw a picture and let's start this up. So right triangle here, I'm going to go ahead and just put theta there. It technically doesn't matter if you put the theta up here, but make a decision on where you're putting it and then just commit, and then the rest of the problem will go from there. So we have our cotangent of theta as 15/7. Right away, I'm going to go ahead and convert that to tangent. So tangent of theta is actually then 7/15. So I'll go ahead and label that. We get no two of our sides right off the bat. I will then go ahead and use my Pythagorean theorem next. Let's call that side x. So once again, using the calculator, that's going to be 49, which is 7 squared plus 15. That's going to give me 274. And when I take that square root of 274, you see in the calculator, I will just get the square root of 274. Now, depending on the lesson, we can either write this as a radical, or if we approximate this, we're going to get about 16.6. So for this lesson, I'm going to actually use decimal approximation. So let's go ahead and just call it 16.6. Okay, we found that. Now we need to figure out our theta. Once again, just like the last problem, I'm going to go right ahead and just use the one that I already have created in front of me. So it'll be inverse tangent of 7 over 15. So we'll once again use our calculator for that. I am going to get 25.01, so actually about 25 degrees. That's an E for angles there. 90 degrees is obviously our first angle because these are all right triangles. They have to be for this to work. This is right triangle trigonometry. And then our next angle is 25, which means our final angle is 65. So just like the last example, it's the same process of solving for triangles here. Just like we've been doing, it's just a matter of converting the reciprocal ratio into its counterpart and then proceeding from there. That's it for this lesson. Go ahead and try the assigned practice from here and hope you all have a great rest of your day.